Quote unquote. Yeah.
Yes. Canadian contribution. When we get live. Hello. Spectacular viewing near Montreal on Saturday. That's good to hear. So, hello, YouTube friends. We are live now. Welcome to our July 2022 episode of Insider's Guide to the Galaxy. We hope you all had a good June and got some good viewing in. And now we're going to give you this episode, lots more Messiers to look at and talk about Canada's contribution to the stars. I am really excited to hear about this one. I took a peek at Chris's notes and there's some really interesting things. So without further ado, the only big update we have from national side of things is we will be sharing coming out soon is our registration for a talk with a CSA astronaut who's working on the Canadarm3, which will take place next Thursday, July 14th at 8 p.m. Eastern. More information will be coming soon in the newsletter and on our social media, so stay tuned for that. But you all, for being part of Insider's Guide, are the first to know because we haven't started advertising it yet. So if you're interested in learning more about Canadarm3 and Artemis and hearing it from a Canadian engineer, sign up for that. And with that, let's hear about more Canadian contributions. I'll pass it off to you, Chris.
Thank you. Yes. So I called an audible just because we had originally planned to look at the summertime planet gazing season, but we've got time yet before those are really going to be in their prime. So we'll defer that a little bit. And I thought I'd jump on the fact that we've got an article in the latest Sky News, which talks about Canada in the stars. And I've wanted to write this for a while. And what I did is I did some research and looked up all the different ways that Canadians and Canadian telescopes and researchers and various things. I'm kind of being loose with the Canadians phrase because sometimes it's somebody born elsewhere who came to Canada, contributed in a major way to astronomy. So forgive me for hopefully it's not false
people
advertising.
like residing in Canada, or they did it in our area.
Yeah.
They don't necessarily need to be Canadian citizens, but it came
Exactly.
from Canadian soil.
Exactly. So I'm not going to talk about Canadian astronauts. I'm going to focus mainly on things that are observable in the night sky that you can go out, on a summer's eve with beverages and a telescope or binoculars and check out a few things. Not all of these are going to be best in the summertime, though. Some of them you'll want to take note of for the other seasons of the year. Sort of fall and winter will be a few of them. I'm not going to talk about asteroids that have been named for Canadians, although there's a great list on RASC.ca, and Samantha can pop the link to that in the chat for anybody that wants to look up the growing tally of Canadians that have asteroids named after them. And I want to shout out to Heather Laird out in Calgary, who gave a great talk on Canadian women in astronomy back, I think during the pandemic, or maybe just before. I can't remember the exact time, but it's on YouTube, and then Samantha can put that YouTube link in as well for anybody that wants to check that out. So that's got people like Ruth Northcott and Sarah Seager and Mary Lou Whitehorne, and all the great ladies of RASC and elsewhere. So that's a great one. Comets, Canadians have certainly pulled their weight in discovering comets. Of course, David Levy is one of our most famous comet sleuths, comet hunters. He has, I think, 22 comets and counting so far. First one was in 1984. His most recent discovery was in 2006. And there's another page on the RASC.ca that tabulates the comets that were discovered by Canadians. So,
and if you're interested in learning more about David Levy's journey, I'm just going to pop the link. He has a memoir called A Night Watchman's Journey. So that'd be an interesting read too.
Yeah. Now, first comet discovered by a Canadian was by Sidney Vandenberg, who we're going to mention today deeper into the program. He discovered comet C/1974 V1 Vandenberg back in the 70s. And then the most recent comet discovered by a Canadian was by our GA keynote speaker, Robert Cardinal, who found 2008 T2 Cardinal. So about 14 years ago or so. And he mentions that in his keynote. So if that gets posted as a rewatch, then you can certainly look up and see what he said about that.
In the works.
Michael Boshat, I'm not sure how he pronounces his name. Hopefully that's close. Searches for comets on the SOHO imagery, which is the satellite that we use to stare at the sun. And it actually captures objects that pass near to the sun. And he's found a number of sun-grazing comets in there, and he got a prize for that work. So that's a great thing for him. All right, so I'm going to share my screen here, and we'll get started on the things we can look at. So I'm starting out with a bit of fireworks, right? Because we just had the Canada Day and the 4th of July, and I thought it'd be fun just to mention some fireworks. This is the Fireworks Galaxy, Caldwell 12. Let me just bring up the thing here. Fireworks Galaxy, Caldwell 12 or NGC 6946. And where this is located, it's pretty bright, magnitude 9.6. So it's a common target of amateur astronomers. And it's up there near the border between Cepheus and Cygnus. So it's fairly nicely placed in the evening sky these days. And the other one, if you want some more fireworks, there's a Firecracker Galaxy. Here's the Firecracker Galaxy. It's up near the nose of the Great Bear, Ursa Major. And this one is a bit of a, fireworks was face-on spiral, and this one's more of a tilted spiral. So this is magnitude 8.9. So those are a couple of neat ones that you can look at for fireworks, to celebrate fireworks, not Canadians necessarily, but just for fun. All right.
They won't scare your animals. So maybe this is a better one to look at.
So let's start off with the asterism. So I mentioned in the article that there's a gentleman by the name of Lucien Campbell. He was a RASC member, well-decorated RASC member out in the West. And he was an avid visual observer. And way back in 1980, was scanning around with his binoculars, and he spied a pattern of stars in the sky that he wasn't familiar with. And that pattern of stars was up here in the northern sky at this time of the year. And he described it, you'll see the quote in the article, as a beautiful cascade of faint stars tumbling from the northeast down to the open cluster NGC 1502. And since he was not previously aware of this feature, he popped a note down to Walter Houston, or Walter Scott Houston, who was the columnist in the Sky and Telescope magazine. He hadn't heard of it either, so he suggested that it be nicknamed Campbell's Cascade, and that's how history began. And here's where it is. So if you look in the northern sky, again, this isn't necessarily the best time of year to see it, but you find the W of Cassiopeia, which is up here in the northeastern sky. And if you take the star Calf and the star Segan and double that line, so from here, I'll just mark it here with my marker here. Take this line and continue it by doubling it. You'll find a modest medium bright star here in Camelopardalis. And that is the sort of anchor point of Campbell's Cascade. If you zoom in here and look at this neat chain of stars running up down through that star. It's about 2.5 degrees in length. So it's a terrific target for binoculars. And what's neat is if you zoom in and kind of pay a little bit closer attention, there are lots of variations in colors of the different stars. So there's some yellowish ones, some blue ones. And you see a lot of pairs that are kind of arranged in pairs, sort of crossways to the main track, almost like a railway track, if you want to look at it that way. And then near the bottom, so we've got here, this is the sort of southeastern corner, southeastern tip of the cascade. You can look for this open cluster, NGC 1502, open star cluster. And that's got a nice double star Struve, or triple star here, actually, Struve 485 in the middle of it. So that's a great one to go for. All right, now he wasn't done discovering his asterisms. So if you scoot up to the upper regions of Camelopardalis. You can see that there's sort of this big triangular. These stars are pretty faint, so it's not that easy to find them, but with binoculars, you should have no trouble. So you want to look for the star Gamma Cam, and then look just a little bit to the upper right here, and you can find Campbell's Kite. This is Campbell's Kite. You can see there's a set of stars forming the string of the kite, and then roughly a diamond shape pattern for the head of the kite. So that's a neat one. And this star, this sort of yellowish star here is V805 Cas. It's a magnitude 6.3, so it'll be pretty easy to spot in your binoculars. All right, he's got one more. So we've got the mini Cassiopeia. The mini Cassiopeia is over here. Let's mute that up. All right, the mini Cassiopeia. Oh, that's not where that one is. Let me just find this one. I'll do it this way. Cassiopeia. Oh, there must be more than one. There we go. This one's over in Draco. So it's in the loop of Draco down here near the Dippers, the small Little Dippers bowl. And you can see there's this upside down W shape of the mini Cassiopeia. So that's another one you can go for.
Amazing how close it actually looks like.
Yeah.
Regular Cassiopeia.
For this one, I noted that you might want to look for, the star Al-Hakan, which is Chi-Draconis, and it's sort of tucked between that and Upsilon Draconis. So it's basically, well, you can see it here. It's in the deep U of the dragon. Of course, the orientation will vary at different times of the year, but most of these are visible now or as we get closer to the autumn and winter time. Now, I got a bonus one for you that wasn't mentioned in the article. This is not necessarily a Canadian asterism, but it's one of my favorites to look at.
Sorry, Chris, question about mini Cassiopeia. How would you suggest just naked eye or binoculars or telescope?
Oh, these are going to be good for both binoculars or telescope at low magnification, but they're small enough that you could certainly put an eyepiece on it and zoom in. I think it's what I have. It's only 19 by 7 arc minutes, so that's half the size of the moon. So that gives you a sense of its scale.
Thank you.
Yeah. So the Stargate is one of my favorite asterisms to look at, and my argument for this one is that the television show Stargate SG-1 was filmed in Canada, starred a lot of Canadian actors. So I'm making that link. I'm calling that's fair. And this one is really neat because you've got a triangle of stars within a larger triangle of stars. And so it's sort of like a double flux capacitor / Stargate. But anyway, it's a kind of a neat object. And I'll just put this in here's the view through a 6-inch Dobsonian with a 26 millimeter eyepiece. So it's a little small. You can certainly stand to magnify that up.
So this is what you refer to as like a telescopic asterism then?
Yeah. That's actually a great point. Not all we're used to thinking of asterisms like Cygnus, the Northern Cross, the Big Dipper, the Keystone of Hercules, but asterisms can go all the way down to telescopic size. Definitely. If you do a little bit of research, you can find dozens of these cute little patterns. There's one in the Club of Orion called the 37 or 47 cluster, where the stars are arranged in like numbers. So that's kind of a neat one too.
In terms of asterisms, I'll just give a plug. We're hoping to have them in the fall as a guest, but the Charles Ennis, who is now our president of the RASC, has been working on an asterisms project, which lists like all the asterisms from all the cultures and where they came from. So if you're more interested in finding more about all the different type of asterisms up there, stay tuned when that will be released as a free resource.
Fantastic. Okay, let's move on. Let's talk about the black hole, the famous Canadian link to the first confirmed black hole. So back in the 1960s, astronomers were sending Geiger counters up in rockets to try to map out the sources of X-rays scattered across the nighttime sky. You can imagine that those patterns or those maps were not very, very accurate. They weren't really pinpointing sources of X-rays, but they were kind of putting them in general spots in the sky. Later on, though, they were able to, kind of get better, a little better at it. And once we started also mapping the sky in radio wavelengths, we were getting some instances where there was coincidence between the X-ray source and the radio source. And around that time in the early 1970s, an X-ray source also gave a radio outburst. We got this radio signal along with the X-ray signal in this patch of sky in the neck of Cygnus the Swan near this star, which is a naked eye star named Eta Cygni, which is about halfway between the heart of the Swan, Saturn, and Albireo, the double star at the nose of the Swan. American astronomer Tom Bolton was actually employed by the University of Toronto at that time, and he was working at the David Dunlap Observatory during the summer of 1971, I think it was. And he decided to look for what was causing this X-ray source, radio source. And he actually found that the source of the radio signals was a star, not Eta itself, but a star in the vicinity. And it turned out that he found a blue supergiant star whose spectra was being Doppler shifted every 5.6 days. So something was actually tugging that big giant blue star around on an interval of 5.6 days, so that the spectra was being Doppler shifted as it approached and receded away from us. So putting two and two together, you've got your X-ray source, you've got something massive and invisible, you've got radio, Cygnus X1, the first confirmed black hole. So black holes were theorized at that time, but Tom Bolton was able to confirm this as a candidate for the first confirmed black hole. And if you want to see that big blue giant star yourself, you can. And this is how you can do it. So find the star Eta in the neck of the Swan. And then nearby, you'll see that there's a not quite as bright star. So Eta is magnitude 3.85. So it's naked eye, no problem. You'll see that there's a little star called GRF 12, which is magnitude 7. A little bit to the, let's put the north up here. This is using a north up. So this is up towards Saturn and down towards Albireo, this view. So GRF1, if you go in the opposite direction, up towards sort of turning towards towards Deneb and Saturn and Deneb, you're going to find a triangle of 3 stars sitting just below the neck in that direction. And once you've got those 3 stars with your telescopes, you've got your Eta, you've got the 3 stars, you want to look in between for a pair of stars sitting right here. And that pair of stars, the one I've got selected, is V1357 Cygni, and that is the blue giant star that is the partner of Cygnus X1. So I've looked at it in my scope. It's not that hard to find it. Anybody that's also imaged the Tulip Nebula in the neck of the Swan may have actually framed it with the Cygnus X1 star in it as well. So that's kind of a neat one to check out.
And if you're interested in seeing more about the telescope that it was discovered with, we have an episode a while back where we toured the David Dunlap Observatory. So check that out in our playlist.
Absolutely. All right. Any questions on anything so far? By the way, if anybody has anything that I've overlooked, Canadian connections, get ready to share them for everyone watching.
No questions so far.
Okay, let's move on to Sidney Vandenberg. So Sidney Vandenberg was born in the Netherlands. He's a professor. He emigrated to Canada, became a professor at the University of Toronto around 1958. And he too worked extensively at the David Dunlap Observatory. And while he was there, he embarked on a project where he was going to use the catalog of Palomar Sky Survey plate prints. So if you ever visit the DDO and you get one of the more behind the scenes backstage type tours of the administration building, there's a giant file cabinet, well, but fairly large file cabinet consisting of trays of prints. And those are acetates and hard copy printouts of the Palomar Sky Survey. I can't remember the dimensions of each print, but I think there are several, maybe might be 1,000 or 2 prints covering the northern hemisphere of the sky. So what he did is he sat down and he went through the stars that belong to 2 catalogs. One was called the Bonner Durchmusterung catalog, and the other was the Cordoba Durchmusterung star catalogs. Those were the sort of brighter star catalogs that predated the Henry Draper catalogs that were generated at Harvard University, in the 20th century. You may have noticed the names, the HD designations on the stars, and those represent the Henry Draper, but these are a prior catalog. So he went through 100,000 stars contained on those plates. Those are all stars north of declination 33 south, so the top sort of 60% of the sky, northern 60% of the sky. And he picked up 500 candidate reflection nebulae. So reflection nebulae are the situations where you get dust or gas near a bright star, and the light from that star is actually scattering off or reflecting off that gas and dust to produce the characteristic bluish glow around the star. So the star is not energizing the gas enough to ionize it and produce the pinkish hydrogen 2 regions that we're used to seeing, but it gives you these sort of characteristic blue glows of scattered starlight. And it's the same principle, the Rayleigh scattering, that makes the Earth's sky blue because of the sunlight. So he came up with 500 of those stars. Then he went through it and actually listed, sort of narrowed it down, and came up with 158 objects that he published in a paper that Samantha can put the link in if you're interested in reading the paper, in the Astronomical Journal in 1966. That's Sidney Vandenberg. Now, you may think, well, what does all that have to do with my observing? Well, you've seen a lot of the objects that he put in this catalog. You'll recognize the term reflection nebula, and probably the most famous one that you've seen will be this one right here. Let me just get this one to pop up. The Pleiades. So that's that bluish colored glow around each of the 4 bright stars, Merope, Electra, Maya, and Alcyone. And he actually, if you can go into Stellarium and you pop on the DSO tab, you can actually identify the VDB. So the Vandenberg class of objects in the Deep Sky catalog in Stellarium are the Vandenberg reflection nebula. And so, so they're about, 159 as of 1968 in the catalog. So if you click on any of these, you'll get the number. So this is Vandenberg 23, 22, etc. So those are your most famous ones. So that's obviously Messier 45 in Taurus. That one's visible in the pre-dawn if you want to stay up late or get up early. Then we've got in the wintertime sky, we've got the Casper, the Friendly Ghost Nebula, Messier 78. And a number of these objects will have more than just reflection nebulae components to them. As you'll see, some of these will also have some dark dust, some emissions, and things like that. But basically, when you see those lobes of blue light, those are the reflection nebulae. We've got some more. How about the Flaming Star Nebula? Some of these are great imager targets for people that want to do imaging. This one's in the center of Auriga. So there's your ring-shaped constellation of Auriga in the winter sky. This one's a little bit more pinkish. So there's probably a combination of effects happening in this one. There's the Seagull Nebula. Seagull Nebula is near Sirius, right? This one, you can see I'll just turn off the sky here so we get a little more impact to it. So mainly we're talking about the sort of bluish glow here and then some of these components here. And then not one that's really good for visual astronomy, but this is the Witch's Head or Witch Head Nebula, which sits just near Rigel off Orion's western foot in the wintertime sky. Now for summertime viewing, what you want to go after is turn your gaze to the south towards the star Antares in Scorpius. And you've obviously seen, you've probably seen pictures of this area, deep, long exposure, deep sky images of this area because it's so beautiful. You've got the glow around Antares. So that itself is a Vandenberg class object. Then you've got other glows. There's the Rho Ophiuchi, multiple star with the blue glow around it here. You've got a nice big one up here. This is the Blue Horsehead Nebula around the star Jaba. So it's kind of extending the triplet of Scorpius's claws just above them. And then all of these other little green squares are little pockets of nebulosity that you might pick up. If you've got a really transparent dark sky, or if you get to go further south where these objects will rise higher in the sky, you can certainly pick them up a little bit better. But definitely imagers can chase down a lot of these Vandenberg objects as well. So that's a summertime pursuit for that one. We've also got the Iris Nebula. So the Iris Nebula is over there in Cepheus, which is here. I'll just turn off the symbol so you can see it. So this is really popular with imagers, and it's a nice sort of compact, bright little nebula that you can pick up in most backyard telescopes on a dark night. And the last one here I've got is nearby. This is the small cluster or the cosmic rosebud, which is a combination of open cluster with the reflection nebulosity around that. And then one of the neat ones that a lot of imagers, if you follow a lot of the imagers on social media, they post a lot of pictures of things like this, are these dark dusty nebulas. This is the Dark Shark Nebula, which is also in Cepheus. So it's part of Vandenberg's list of objects. So as I said, if you're using Stellarium, you can look for the VDB objects in this list here. If you're using Sky Safari or Stellarium, I think you can search for Vandenberg objects in them as well. All right, so let me just put back my regular. Any questions so far?
I don't see anything so far. As always, you can use the Q&A or we're monitoring the chat on YouTube and in Zoom.
Cool. I mentioned, I noted that a gentleman named Emil Ivanov actually went about grabbing images of every Vandenberg object, and there's a neat gallery that he put online that Samantha can put the link in the chat if you just check that one out. All right, let's switch to the moon then. The moon's up all the time, so we get to look at it every month. It's a couple of different ways we can approach this. First of all, we've got craters on the moon named for Canadian astronomers, but the unfortunate part of that is that they're unobservable on the far side of the moon. So we have a crater for Dr. Chant, Clarence Chant, the founder of the DDO, and Helen Hogg. And I think what I'm going to use to show you them is this neat tool, online tool called Moontrek from NASA. Let me just open this up a little bit here. And when you go into Moontrek, there are tools here and there in the various corners of the screen. You can see down here in the lower left corner, the default view is this. So when you first log into the site, you'll see kind of this stretched out rectangular moon map. If you click on the projections button down here, you can ask for a 3D globe. And now you've got a globe of the moon that you can roll around and you can zoom in and zoom out. Down here in the corner, you've got a couple of tools. The base maps tool, if you click on this and open it, what this does is it actually offers you detailed views. So, bird's eye views, if there were moonbirds, of some of the, say, Apollo landing sites and things like that. And if you zoom in on, let's say, Apollo 11, which is down in here, you'll see that it'll throw up additional frames, additional imagery. And then if you find that distracting, you can just flick the switch and that turns that off. All right. So let's go through a few of these. You can use this tool to actually fly to specific craters. So for example, let's talk about Dr. Chant. So Clarence Chant was born in Hagerman's Corners, Ontario. He lived from 1865 to 1956. He was the first director and founder, so to speak, of the DDO in Ontario. And for a long time, he was editor of many of the RASC publications. And his crater is on the far side of the moon. Here we go. And this is this little roundish crater. It's 38 kilometers wide, 33 kilometers wide, and it's down near here. This is Mare Orientale. So if you tuned in for our lunar basin sort of tour that we did a few months ago, this Mare Orientale, we can just see the edge of it from the Earth-facing side of the moon. So he's out of sight down there. Hogg. Now, the crater on the moon named Hogg is technically named for Helen Sawyer Hogg's husband, Frank, which to me is problematic. So I think from now on, I'm going to refer to it as Helen Hogg's crater. You can be with me or not, but I'm going to do it that way.
I'm on your side.
Fortunately, she is also out of sight, but she's was actually born in Lowell, Massachusetts. Her husband was Canadian. They got married and returned to Canada to work and make quite a name and quite a contribution to astronomy in Canada. For a while, they were at the Dominion Observatory out west, and then they became management or directors of the DDO. And Helen Hogg also went on to be RASC president and write popularizations, do weekly articles in the Toronto Star newspaper. And she's just a hero to us, especially those of us that volunteer at the DDO. So her crater is to bring that up into view again.
We also have a lecture every year shared with Casca in honor of her as well.
Yeah, so that's her little crater there. And it's, again, on the far side of the moon. I noted that it was, it's just sort of kind of in the middle of nowhere, but that's what we get. All right, next one up is John Foster. So John Foster was from Clarence, Nova Scotia. He was a professor of physics at McGill. His crater is relatively small too. Let's find that one. There you go. Nothing too distinctive about that one. You can see that you've got the chains of ejector craterlets emanating from the Mare Orientale, sort of heading up towards his zone. Then we've got McKellar. So Andrew McKellar was born in 1910, lived till 1960 from Vancouver, British Columbia. He was an astronomer at the Dominion Astrophysical Observatory. He specialized in molecular spectra. His crater is a little bigger. It's 51 kilometers across, and it's near the north edge of the Aitken, the far side Aitken Basin, near the south pole of the moon. That's this giant, dark, low-lying region on the far side of the moon. And last up, we have Robert Petrie. Last up on these far side craters, I should say. So Robert Petrie was born in 1906 in St. Andrews, Scotland. He came to Canada, became director of the Dominion Astrophysical Observatory, and was an astronomer specializing in the luminosities of B-type stars. So that's his crater there. All right, so let's just reset here and we'll talk about the ones that we can look at with our telescopes.
I find it interesting. A lot of these people we've talked about has either worked with the Dominion Astrophysical Observatory or the DDO. So quite a lot of research coming out of those two locations.
Yeah. So if you're using this tool, if you go down and click the little house-shaped icon here, that resets it. So it puts it back to the square on the Earth-facing hemisphere for us. So we've got the north pole of the moon at the top, the south pole at the bottom, east is on the right, and west is on the left. East is always defined at where the sun rises on a world. And so the sun rises as the moon waxes. That's how you define the lunar coordinate system. So the RASC Isabel Williams Lunar Observing Program, as well as a number of the probably Observe the Moon Telescope program, I think will include most of these craters I'm going to talk about, but definitely they're in the Isabel Williams. And that's in the handbook, and Samantha can always pop in a link to that if you're interested in seeing some details on that one.
I've also shared the link to this online application you're using. If anybody wants more of a deeper dive later, it's in the chat.
Yeah, it's a neat tool. You can do things like, if you click to the upper right here, you can actually calculate the distances of things, plot profiles. There's all kinds of neat things you can do with it. So the first crater I'm going to talk about is Banting. We've actually mentioned Banting when we did our walk through the Sea of Serenity episode a while back. So this is Mare Serenitatis. You have the crater Bessel, which is down here south central with the ray running through it. And then Banting is this little wee crater in the middle. This little spot right here. So that's Banting. So that's visible in pretty much any size of a telescope. You do need to crank the magnification up for some of these smaller craters though. So Banting is named after the discoverer of insulin who worked at the University of Toronto. He's from Alliston, Ontario, lived between 1891 and 1941, Sir Frederick Banting. Next up, we have Simon Newcomb, the crater for Simon Newcomb. So Newcomb was the mathematician and astronomer who was born in 1835 in Wallace, Nova Scotia. He worked at the U.S. Naval Observatory. He specialized in planetary motion, and you can see his crater in a backyard telescope. And this one is neat. I think this is one of my favorite ones. Let's see if this one here. So there's Newcomb. So Newcomb is like an upside down snowman. Can you see the three, one crater, two crater, three crater? So body, chest, and head. And in a Newtonian reflector, this gets flipped the right way up. So the snowman is sitting the right way up. So that's kind of fun.
Another fun fact about Simon Newcomb is we do have a RASC Award named after him for people who have do excellent astronomical writing for the RASC Journal, newsletters, publication. And we have this year's winner of this with us. Chris Vaughn won the Newcomb Award this year, and it was announced at the GA, not this past weekend, but the weekend before, for all of his work that he's done with the Toronto Centre and the weekly Skylights and Sky News magazine. And they didn't include Insider's Guide, but I think they should have.
Please.
I have to say that. You've done great work.
Thank you. Yeah, easy to find. So look for Mare Crisium. There's Mare Crisium. You might remember that Mare Crisium has that neat asymmetric ray system from the crater Proclus that's on the western edge of Mare Crisium. And so if you go up from there, you can find the Newcomb crater right above it. So that's kind of an easy location. So those two are easy to find. Next up, I have Daly. So let's look for Daly. So Daly is down here south of Mare Crisium. There's a sort of a dual two fist bumping craters that you can take a look for right below Mare Crisium. So Daly was named after Reginald Aldworth Daly, born in Napanee, Ontario in 1871, graduated from University of Toronto, and he was a highly honored professor of geology. So remember that craters on the moon are named after scientists, explorers, and things like that. So we're not talking necessarily just astronomy in this case. We're talking about science. So he was a geologist. So that one you can find. Let's see, Cook. So Cook is named after Captain Cook, and Captain Cook, as was, you'll note that was mentioned in the article, has a troubled background, but for completeness, I'm mentioning Captain Cook's crater. He did a lot of work in as a British naval officer. He came to the colonies, did a lot of work in Canada, mapping our coasts and working with our sea charts and things like that. So it's named after him. And there you can see his location is. So this is Mare Fecunditatis. So Fecunditatis is the one that has the Messier-shaped ray craters here. And then there's a lobe sticking out below that. And where's her? Let me just highlight it again here. Cook is this one here with the little craterlet inside of it. Okay, now we get to the last three are going to be challenging ones. So the first one we have to talk about is Plaskett. Plaskett is named after John Plaskett, born in 1865 in Hickson, Ontario, another director of the Dominion Astrophysical Observatory, another president of RASC from 1914-15. And this one is located at the lunar North Pole. So I'm just going to wind back here, and I'm going to wind up here and see if we can find Plaskett at the North Pole. This one is visible during favorable lunar librations. So the moon rides up and down and sort of nods up and down and tilts left and right. And at those times when the moon is riding low in its orbit and tilted, the North Pole of the moon is tilted earthward a little bit. We can see a little beyond the North Pole of the moon, and we can actually catch a glimpse of crater Plaskett. So let me just point out where it is here.
Now, this would be one of those craters that are listed in the more challenging lunar observing.
Yeah. So this one here, it's got a nice central peak to it. And again, if I wind back, you'll notice that it's sort of sits. So there's crater Plato. So this is the Earth-facing hemisphere of the moon. It's sort of just directly beyond the moon's North Pole. That's Plaskett. I did note in the article that the next really good libration to get a glimpse of it will be around August 12th. I noted that the moon was librating with the North Pole towards us. So you can see if you can catch a glimpse of it then. All right, so that's that one. Let me just hit my reset here. And the last two are on the eastern limb of the moon. So we have Avery. Avery's named after Oswald Avery, who was born in 1877 in Halifax. He was a U.S. physician and a DNA researcher, and it's not close enough to the edge that you must have libration, but it does help. Let me just show you where it is. So Avery is, you can see it's on this is Mare Smithii. So Avery is this little wee crater that's on the just near side, the Earth sort of facing edge of Mare Smithii. So you can pick it up as a little blotch when the conditions are right. So that one's only 9 kilometers wide. He didn't rate a very big crater. He was a U.S. physician and DNA researcher, if I didn't already mention that. This libration of the moon's eastern limb will be exceptionally good at the first few days and the last few days of December 2022. So we have a month, a cycle of the month lets us get a little bit of it at the beginning and at the end of the month. Last up I have here is Beals. So Beals is named after Carlyle Smith Beals, who was born in 1899 in Canso, Nova Scotia. He was a DAO astronomer as well, also another RASC president from 51 to 52, and he was a recipient of the Order of Canada. This one's near the northeastern limb of the moon, and I think this is a little trickier to see. So there's crater Beals, and I think I can go back to Stellarium and show you some of these that way, so you can sort of see it. If Merocrisium is nice and healthily separated from the limb, then you've got your better opportunity to see Beals. So I would like to, I think we should campaign to recognize more people on the moon. Definitely, we've got some candidates in Heather Laird's video that could certainly warrant being included on the moon for sure. One of my personal favorites or heroes was David Strangway, who is passed now, but he was president of UBC, and he was the head of the geology department at University of Toronto when I was there, and he was heavily involved in lunar exploration, especially Apollo 17, using a form of radar to do the lunar subsurface. So people like that, I think we can continue to memorialize some of these people on the moon. Also, we want to consider the contributions of Indigenous people. We talk about, discovering asterisms and things like that. It's definitely possible that some of these features that we see in the sky were recognized long before we came along by Indigenous sky watchers. So, we don't want to take too much credit, more credit than we deserve for some of these as well. So it's up to them.
I have a question for you. How many of these Canadian craters have you actually seen yourself? All of them, or?
Yes. No, I haven't seen Plaskett, I don't think. I think Plaskett's the only one I haven't seen yet.
And I will say Newcomb and Cook, if you're looking for ones that are easier to see, those would be the ones you'd want to go for. You still need a telescope. From my experience, I think I've seen both of them, but they are probably the easiest on the list you've mentioned. I'm talking about general people.
Yes, let me just bring up. So let's just advance a few days into the month. So a few days from now, and I'll bring up my search here. Just want to make sure put my moon names on. So if you're wanting to search for craters and features on the moon, you want to go into your sky and viewing options, SSO, your solar system object tab, and switch on planetary nomenclature. And you can actually change the color of the labels. I've got mine turned to a gray, so they're not obscuring the moon too much. I think by default, they're a brighter color. But if you want to now search for a crater like, let's say, Avery, then it'll show up as Avery bracket crater moon. And you can see it's right on the edge here at this particular time. But I think I said, August 12th? Look at that. See how it's getting better and better? Mm-hmm. August 8th, 9th, 10th. That really conveys the idea of the effective libration to make some of these features more visible. And Plaskett, let's do the Plaskett one in December. So Plaskett. So it's kind of out of sight in the dark part. And if I jump into December, let's go to December. Let's see, 2, 3, 4, 5. So Plaskett is now kind of here, sort of within closer than the actual northern edge of the moon. Mm-hmm. Yeah. All right. So if there are no questions, we'll go on to Messier Minutes.
So I'll also ask, we heard somebody mention a Rush song, but does anybody have any other notable Canadian contributions to the stars they want to share? I know we talked about during the GA, we'll go into detail, but we did have a Canadian, not on Canadian soil, so I don't think it falls under, discover a supernova in 1987. Ian Shelton, who worked at the DDO as well.
Yeah.
There's another one. It's SN 1987. I don't know if we can see it in the sky or not.
It's, I think it's, let's see. Let's try SN 1987. I'm not sure if this works. There we go. SN 1987A.
In the Magellantic Cloud, large in the dwarf satellite galaxy.
Yeah. So it's You'd have to do your trip to the tropics or further south to see the Magellanic Clouds. That's where that is.
Yes.
He was working in Chile at the time. That's when he saw it.
Yeah, Las Campanas Observatory. Yeah, another interesting connection.
Okay.
Yeah, I don't think we have any questions and no one else. So we do have a big long list of Messier minutes. So we got plenty of time. And I'm going to just say, for my own sake later when I edit, Messier minutes will start now.
Let me just reset the stage here a little bit. Let's go back to tonight. So obviously we've got a waxing moon in the sky nowadays. So it's not necessarily the best night to get out and look at dim Messier objects, but we're not coming back for another 5 weeks or so. So
September 13th. So we do have almost 2 months.
We've got one in
August. 1 August. Yes.
Yeah.
Sorry.
I think somewhere around the middle of August we've got another session. So you'll have plenty of time to fit these in between now and then. Mm-hmm. So let me just bring up my Messier objects list here.
So hopefully when everybody's traveling to their dark sky preserves, as we all love to do in the summer, you will have this list in hand. We can only hope.
Right. So, now that we're into the July and then we'll be into the August, we get some of the real Messier all-star objects. I mean, the showstoppers, the one we really, really love to look at.
First behind me.
Yeah, exactly. So what I'm going to suggest though is I'm going to focus on some of the more southerly, the lower in the sky ones, and you'll see here from Stellarium that we've got July 5th. Really, they're going to be highest in the south, kind of at midnight to maybe 1 a.m. this week, and then as each week passes from here, they'll reach that point about half an hour earlier than that with each week that we pass. But assume for now that you're going to get them when they're kind of at their highest, when they're over the southern horizon. So the first one I've got on my list is Messier 6, otherwise known as the butterfly cluster. This is a large and relatively loose open cluster. It shares the sky with Messier 7, which we'll come to in a second here. You should be able to see this in any size of a telescope. Binoculars, you should have no trouble as long as the air is pretty transparent. We're talking about low to the sky, so you're looking through lots of air, so you do need that transparency to see it. So it is rather low for us Canadians, especially those of us that are viewing from the prairies where things are even lower in the sky than they are in Eastern Canada. It's located, so I noted here that's located halfway along the line between, we need to get to know the teapot here. So we'll just set the stage for a minute here with the teapot. We've got the bottom of the teapot, we've got their handle on the east, the pointy lid, and the spout on the west. So bear that in mind. And what I'm going to be pointing to a lot of these stars here as we go. So the way to find M6, if you're not too sure, is you can start at Caus Media, which is where the lid meets the spout, and extend the line over towards sort of the neck of Scorpius, and Messier 6 is almost halfway along that line. So that makes it pretty easy to find. And it's also above the double stars, which are the stingers of the scorpion as well. So you can do it that way. In a telescope, let me just pick this up and go to the Dobsonian telescope view. So this is a magnification of about 35 power. So you can see it's nice and sparse. Lots of nice little blue stars in it. You're going to notice one star is not like the others. And that's this little star named BM Scorpii. So this is kind of a K-class star, whereas the others are more bluish. Do note the star patterns in the cluster. See if you can see the butterfly shape out of it. And fun fact, this one is the closest Messier object to the center of the galaxy in angular degrees. So not in physical space, but in angular degrees. So the galactic center is just above the spout of the teapot here, and it's actually the minimum distance away from that. All right, M7 is up next. So Messier 7 is, you can see already, it's huge. It's Ptolemy's cluster. It's been known since antiquity as a bright little patch of stars in the sky. It's the southernmost Messier in Messier's list. So it's the one that's going to be the most challenge for the clearance above the southern horizon. I've been able to see this with unaided eyes, so definitely binoculars too. In your telescope, don't power the magnification up too high because it's really big. I think it's almost three times the diameter of the moon, the cluster in size. And again, you can use the star Caus Australis, so the base of the peak, and draw a line down to Shaula. So if you do that, you can see it just sits, a finger's width or a thumb width above the midpoint of the line between those two stars. So it's pretty easy to find as well. All right, that's M6, that's M7. Oh, and by the way, if you want to see it in a telescope, it starts to really be sparse if you magnify it too much. All right, next up is Messier 8. Messier 8, we're going to go up a little higher, so this will be a little bit easier. And this is one of the real celestial showpieces. This is better known as the Lagoon Nebula. So it's a bright emission nebula. It's fairly large. It's about triple the moon's diameter in the sky. So it's fairly wide. You should be able to see it as a bright patch with your unaided eyes on a nice, dark, clear night. And definitely you can pick it up in binoculars as well, and then any size of telescope. It's located above and between the teapot peak of the lid and the spout. Or let's see, I think I said you can double the line from Nunkie. So let me just find Nunkie. So Nunkie is the top of the handle of the teapot. So if you draw a line from Nunkie to the teapot lid and just double that, you're going to end up at the Lagoon Nebula. You should be able to see in a bigger telescope. You can look for internal structures. So you can see there are darker lanes of dust and gas. You can see these so-called Bok globules. These are sort of little comet-like tadpole sort of features in a bigger telescope or in an image. And those are basically coalescing regions where the stars are beginning to form. I noted that if I used an oxygen 3 filter or a UHC filter, that it even got bigger. So that's something that you really want to put on that if you have it. You'll also may want to notice the internal star cluster inside. That's NGC 6544 is the star cluster that's inside. And there's a pattern called the hourglass, which is sort of revealed in the brighter, sort of central, most bright section of the nebula, the glowing nebula. So look for that one as well. All right, now we have just above that, we've got Messier 20. Messier 20 is the famous Trifid Nebula. So this is, as you can see, quite a bit smaller, quite a bit less intense. So you're probably going to need binoculars for sure. Maybe you'll get them in binoculars on a good night. And definitely you want to use any size of a telescope. And again, this one is so called because it's got the lobes of gas divided by these dark dust lanes, which splits it into lobes, at least 3 lobes, maybe even 4. You've got a combination of the pinkish color here is from emission and then the blue from the reflection nebula. So it's also a Vandenberg object. It should be. I don't see the Vandenberg, but maybe not. Let's see what else. We've got, you can use nebula filters, but the nebula filters won't brighten the reflection nebula side. I should have mentioned when we were talking about Vandenberg, because reflection nebulas are reflecting starlight, then filters that brighten emission nebulas and darken the stars will also darken reflection nebulas. So those won't help. Let's see what else we have here. To find it, you can use, M8 if you want to do it that way, or let's see, you can look for the line from this star. So you can take Namasadira through the peak of the teapot lid and just sort of double that, and that gets you in the same neighborhood as well.
For people who are sorry, I was going to say for the Lagoon and the Trifid Nebula, we also, if you're interested in editing or playing around with data, there's free data sets on skynews.ca to learn. I find when I edit the data, I start to notice more details in the actual object itself.
Yeah, and these are great candidates for sketching at the eyepiece as well. Try to capture their shapes and their internal structures. In the Trifid, when you're looking at it, pay attention to the stars inside. There's a little grouping of stars in the center, and they're kind of like a little mini trapezium, like in the Orion Nebula. So that's kind of a neat feature to pick up as well. And you'll probably end up putting both of these objects in the same field of view, 20 and 21. So we'll go to 21 next. Oh, by the way, let's just look at 20 in the eyepiece view. So that gives you an idea of the size of it at 35x.
I've also noticed sometimes too in the wider astrophotography, people can sometimes get both the Lagoon and the Trifid in the same.
Yeah.
Yeah. So you might see those together if you look them up online. I have a question from myself. So I noticed you doing the line from the top of the teapot, but from Polis, that star here, how far, if we just kind of found that star, how hard would it be just to aim it at that general area where M8, we see M8, M20, M21 would be?
Yeah, let me put on binoculars. I'll put a circle on for binoculars just to give a sense of scale. So there you go there. So if you put the star Polis in the upper left corner of the binocular, you should capture all three of these in the rest of the field. So we're talking about, I think it's about 4 degrees, 2.5 to M20 and 21, and about almost 4 degrees to M8. Yeah, so that's a great way of doing it.
I usually recommend people when they're looking for asterisms / constellations for the summer sky is to find the Scorpius and the teapot, and particularly the top of the teapot has a lot of stuff. So if you get good at that, you'll be able to find a lot of these. And
the bottom of the teapot, spoiler alert, we'll get there in a minute. Okay. Messier 21 is up next. So Messier 21 is an open cluster. You might see the name Webb's Cross associated with this, but there's kind of a twist to that name. This one basically shares the eyepiece with M20. So when you found one, you found the other. You want to see this. So this one you should be able to see in binoculars, any size of a telescope. And the more aperture you have, the more stars you're going to pick up, because this one is a mixture of a collection of brighter stars and then dimmer stars beyond and between. So you'll be able to pick more stars up as you go. Try to make note when you're logging open clusters, how many stars you estimate there might be, and maybe the ratio between bright and dim, that kind of thing. Those are great features to mention. Let's see, the Webb's Cross name. So the Webb's Cross name actually refers to these sort of magnitude 6 and 7 stars between the two deep sky objects. So sort of there's a star here, 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 here. It kind of makes an upside down crucifix, that sort of thing. And if you put, let's say, this one, let's do a telescope view so that I can sort of see the cross, sort of a crooked cross shape inverted in the reflector telescope view. So that's what really the Webb's Cross is referring to. All right, Messier 28. So Messier 28, we're gonna dash down towards the peak of the teapot. So Messier 28 and Messier 22 sit flank either side of that. So Messier 28 is a small, but it's an easy to find because it sits so close to Caus Borealis, the star at the top of the teapot. You can see this one in binoculars, any size of a telescope. It's just really a finger's width between the peak of the teapot lid and the globular cluster, so that makes that easy. When you're looking at it, you want to look for, here's the same view at 35x. You can see it's pretty tame, pretty faint, but it should stand out. There's a bright field star here to the west of it that you can pick up. And then, as I said, you're going to look for, when you're looking at these globular clusters, as we talked about a few weeks ago, Want to look for the density profile. Is the core concentrated? Is the core loose? How long does it take for the stars to kind of spread out? All those kind of features. You want to look for the shape of it, that kind of thing. This one's about 17,900 light years away. So, and there is another little globular cluster just to its east. So let's see if I can pick that one up. Let's see. There should be NGC 6638 nearby. Yeah. So there's another little globular cluster, not a very bright one, just on the opposite side of the star from M28. All right, M22. M22 is an easy one. It's huge. It's bright. It's one of the best globular clusters in the sky. In fact, if it weren't sort of extincted by being so low in the sky, it would definitely be rival M13 as a summer favorite. It's sitting here, easy to find. It's just to the upper left of Caus Borealis. So that makes it easy. You can see it, as I said, naked eye, any type of telescope, binoculars, and you want to look for its density profile. You want to note its shape. So it's actually a little bit egg-shaped, and there are some streams of stars extending around it, that kind of thing. So make note of features like that when you're looking at it. Okay, now 3 more. And these are along the bottom of the teapot. So there's actually a kind of an alley, a globular cluster alleyway sitting here across the bottom of the teapot. 3 Messiers, and there are actually even some other globular clusters in addition. I don't have the symbols marked for them right now. So let's start with Messier 69. So Messier 69 is the most westerly of the trio at the bottom of the teapot. Again, it doesn't get very high for Canadians, unfortunately. When it's culminating, though, you should be able to see it with your binoculars, but really telescope is the way you want to go. If you've got a telescope, you're going to need that to kind of really see the core and get the details in there. It needs a good deal of magnification to get those details. There's an idea of it. It's located about 2 finger widths, okay, to the upper left of Caus Australis, which is the sort of base of the spout of the teapot, and on the line towards the opposite corner. So you're sort of heading in the opposite corner. And you're going to, the other way you can look for it is if you can find Caus Australis and look for a couple of medium bright stars sitting here in the corner of the teapot, and it's right above those. So that's another way you can find it. This one's about 29,700 light years away. All right, next up we have Messier 70. This one's easy because it's almost exactly halfway between Caus Australis and Acela. So you can just pop your finder in the middle of the 2 of them. This is actually, though, the dimmest of the trio. So you can see its symbol is a little bit smaller. And just turn off the symbol, you can get an idea of it. Not as large, it's a little more concentrated. You can get it with binoculars when it's culminating, but really it's a telescope target. Let's see, you need a bigger aperture to sort of expand the core or resolve the core in any way. And again, this one's got some shape to it as well that you want to take a look at. And here's the view at 35x, fairly small. And last up here, we've got Messier 54. Messier 54 is the easternmost of the trio. It's far. It's the farthest globular cluster in Messier's catalog. It's 87,400 light years away. And if it were as close as some of these others, it would be enormous in the sky. So it's a real mammoth one. Possibly it doesn't even belong to the Milky Way. It probably belongs to one of the Milky Way's dwarf galaxies. So it'd be considered to be extragalactic in that sense. There's evidence that it may have a central black hole inside it. That's fun. Again, you can kind of just turn your gaze a couple of fingers widths to the right, to the west of Acela in the corner of the teapot, and just look for it that way. It should be pretty easy to pick up. Because it's so far away, though, it really is hard to resolve any of its stars. So at low magnification, you can see here, it's just a small smudge, a small fuzzy star. So you really want to crank up the magnification on this one if you're taking a look at it. And I think that's it. Good luck with those, everybody.
At least we only really have to look at one area in the sky. So once we find the teapot, we're in this, as long as we stay within that constellation boundary, we'll see most of them.
Yeah. Next time up, we're going to venture to the north and catch this group that's sitting up to the north of the teapot.
So if you want to skip ahead. Does anybody have any questions about those Messier objects or anything we've talked about today? We will be posting the Messier Minutes notes. They will be coming shortly after the end of this, when we're done here. And they'll be on the regular rasc.ca/Messier-minutes.
Perfect. Well, hope everybody gets some clear skies and some dark skies. The moon is back now, but it'll disappear again before long. And we'll pick up some nice couple of weeks of dark skies before we're back. So good luck with that.
And look at the moon while it's up there right now. I always say there's so many things to look up on the moon. Try to find those Canadian targets we talked about.
Absolutely. Absolutely.
And so when are we back next, Chris?
I think we're back.
You have to update the question calendar online.
We're back on August 16th.
August 16th. Okay, we'll post that on the website and what we're going to be doing. So if you're interested,
I think we can do the planets then.
Yeah, the bright planets in the sky. Perfect. Yeah, so keep track. As you know, our summer schedule is a little laid back because we want to get out, have a vacation, do some stargazing on our own in nice weather, and we hope you all get the chance to do it as well. So keep watch on the rasc.ca/insiders guide, and the Zoom is updated to only give you notifications for those days that we will be doing it. So thank you all. Hope you get, as you said, clear skies and get to see some of the Messiers and targets we've seen today.
Yeah. Keep looking up, unless you're looking to the south, then you're looking a little bit down, but that's okay.